The next example that we're going to work through is very similar to the first example we just finished, with some differences, specifically differences in variables. Let's take a look at this and see similarities and differences. It says the quadratic function h of t equals negative 4.9 t squared plus 52t plus 12 models the height in meters h of t of a projectile t seconds after it was launched from the edge of a cliff. The height is measured from the bottom of the cliff, which we're going to call ground level. So first things first, what is the independent variable and what is the dependent variable? Because it's written in function notation, we can easily identify t as our independent variable, which is equal to time. And identifying units, that's in seconds. Which means that our dependent variable is h. H up here is height in meters. So height in meters. Okay, so height is dependent upon time. So this is the key difference in this function compared to the first example that we looked at. Here, height is dependent upon time since the projectile was launched, whereas in the first example, height was dependent upon horizontal distance traveled. So the first example we did, the variables were horizontal distance and height. Here, no more horizontal distance is represented in our function, only time and height. So the height is dependent upon time. Now we can see that this would be the case in that if you throw something in the air, the height changes over time. It increases in value and reaches its maximum point, and then it decreases in value and comes back down because of gravity. So we have our variables identified. Next, what is the height of the cliff from ground level? What is the height of the cliff from ground level? So it said that this projectile models height of a projectile launched from the edge of a cliff. However, the model says that the height is measured from what? Is measured from the bottom of the cliff, which we are going to call ground level. Well, from the previous example, we recall that the initial value is our value of c. So in our function, c is equal to 12. 12 is our initial height, which means that that is the height of the cliff from which it was launched. So we would say that the height of the cliff is 12 meters. 12 meters above ground level. So what that may look like physically, okay, is that here is ground level and here is the cliff. And it's from this edge right here that the projectile is launched. And that value of c tells us that that cliff is 12 meters off the ground. So again, the value of c up here tells us our initial value. Next question that it's asking us is, what is the height of the projectile after 4 seconds? So again, in this type of problem, it's asking us for something and telling us for something. In this case, it's asking us for height and telling us time. It's telling us that time, t, is equal to 4. Well, if we want to find height when t is 4, that means we're looking for what the height is after 4 seconds, so h of 4. And in our case, that is equal to negative 4.9 times 4 squared plus 52 times 4 plus 12. Plus 12. So let's really quick grab our calculator here. Okay. And we are supposed to do, let's clear this out, we're supposed to do negative 4.9 times 4 squared plus 52 times 4 and plus 12. We end up with a height of 141.6. So this right here is 141.6, and the units of our height is in meters. So after 4 seconds, well, from 4 seconds after launch, our projectile is 141.6 meters in the air. Okay, this next question is an interesting question. It'll cause us to remember one of the principles that we looked at the beginning. It says this: what is the maximum height the projectile reaches? And how many seconds does it take to reach that height? Now we recall from the very beginning that anytime we were asked to maximize or minimize anything, we need to find the vertex, because the vertex is either your maximum or minimum point. So let's go through the process of finding our vertex. We know that the x-coordinate of our vertex is negative b all over 2 times a. What does this equal? Well, we know our b value is 52. Okay, from our equation, our b value is 52. Let's write those down really quick. Our a value is equal to negative 4.9. Our b value is equal to 52. And we already know that our c value is equal to 12. So back to our problem, negative b. So that's going to be a negative 52 divided by 2 times a being negative 4.9. Okay. So this is going to equal negative 52 all over negative 9.8. 2 times negative 4.9 is negative 9.8. Getting a final result for this, okay, we want negative 52 divided by negative 9.8. Enter, and we get a 5.31. We'll round it to 2 decimal places. So this is equal to 5.31. So the x-coordinate of our vertex is 5.31. To find the y-coordinate of our vertex, we simply take our x-coordinate, plug it in to the x location of our equation. So we essentially want to find what negative 4.9 times 5.31 squared plus 52 times 5.31 plus 12 is. So we're plugging the x-coordinate into our function and solving for y in order to get the y-coordinate of our vertex. So finishing that off, we end up with what? Negative 4.9 times 5.31, that gets squared, plus 52 times 5.31 plus 12. Enter, and we get 149.96. 149.96. 149.96. So we now have our x and our y coordinate of our vertex. So our vertex coordinate point is 5.31, comma 149.96. Well, back to the problem, it says this: what is the maximum height the projectile reaches, and how many seconds does it take to reach that height? Well, if we remember, we already identified what our independent and dependent variable are. Well, for us, instead of t and y, x is the generic independent variable, and we knew our independent variable was t for time. And y is the generic dependent variable. We already know that in our case, our dependent variable is h. So we know that the maximum height our projectile reaches is 149.96 meters. and it takes 5.31 seconds to get to that height.